In continuation of lecture number 7, first part of lecture number 7, here we will discuss the canal lining. Okay, the advantages and the types of the canal lining. Okay, so before going into the main topic, let's discuss some background that why the canal lining is necessary. Should a canal be lined or not? Okay, so let's see the background mechanism is when we design an irrigation canal for the conveyance or transportation or carrying up irrigation water from the source and to point of the utilization. Okay, so see, if here is a water source, that is a natural source of the water, that is a river or lake or stream, or it is a reservoir, and if we construct an irrigation canal up to the point of utilization, mean up to the field. Okay, so see, if you enter some amount of water into the canal, for example that is Q1, so the water which is available at the head of the field, that will be Q2, and it means that the discharge at the head of the field will be less than the discharge at the head of the canal. Okay, so that difference is, okay, that Q1 minus Q2, okay, divide by Q1, that will be considered the amount of loss. Okay, that will be considered as a losses in the irrigation canals, and if you multiply it by 100, so you will get the percentage of the discharge which is lost from the point of the head of the canal up to the point of the head of the field. Okay, so see, there are different types of losses in the canals. Okay, so majorly one, we have the evaporation losses. Okay, mean when the water is transported, when the water is allowed to convey in an irrigation canal, so some amount of water will be lost in the evaporation, which is called the evaporation losses, because it will have some pre-surface and the sunshine rays or the radiation will be falling on the surface of the water, and some amount of water will be lost into the vapor state. So that will be a type of loss, that will be a type of evaporation loss. Okay, so see, evaporation loss depend on two factors. Okay, one is the climatic factor. Okay, suppose for those area where there is temperature is high, if there is low humidity or the wind velocity is high, so we can say that the evaporation losses will be more. Okay, and also the evaporation losses is depend on the canal factor. Okay, for example, if the surface area is more, so then more area will be exposed into the atmosphere and the evaporation losses will be more. Okay, also depend on the depth of the water and the velocity of the water. Okay, so major portion of the water is lost in the evaporation. Almost we can say that 20 to 50% of the canal discharge in unlined canal has been lost. Okay, mean that is the total loss. Mean if you have an unlined canal, if you have the canal in the natural environmental condition, in the natural soil condition, then 20 to 50% of the water will be lost. Okay, so evaporation is one of the major contributor into the water losses in the irrigation canal, and evaporation losses depend on two factors. One is the climatic factor, in which the temperature, humidity and wind velocity is involved, and second one is the canal factor, in which the surface area, the depth of the water and the velocity of the flow is involved. Second type of the losses is the seepage losses. Okay, mean the seepage losses. See, the amount of water which is entering from the water body. See, in an irrigation canal there will be water. Okay, so the water, if the canal is unlined, if the canal is of the natural condition, then the water will be entered into the soil from the water body, that is called the seepage losses. Okay, the water will be absorbed by the soil. Okay, the water will be percolated into the soil, and it depend on the soil type and age of the canal and shape of the canal, and also it depends on the groundwater table. Okay, so seepage losses is also one of the major contributor which is contributing into the canal losses. And the third one is the transpiration losses. Remember, if the canal bed is of the natural soil, okay, if it is of the clay soil, for example, or of the fertile soil, then the plants will be growing in the canals. Okay, suppose at the sides of the canal, at the banks of the canal, or at the beds of the canal, different types of plants will be grown there. Okay, so it will also utilize some amount of water from that transporting water. So that will also contribute into the water losses in the irrigation canal. But remember, the transpiration losses is not that much contributor as the evaporation losses and seepage losses. So then the transpiration losses are we can say that neglected. Okay. And one thing more, the losses in the canal is represented by different units. Okay, for example, if you have an irrigation canal, so it will have wetted perimeter, it will have wetted area. Okay, so how much discharge has been lost in 1 million square square meter? Okay, if you have 1 million square meter wetted area, so how much discharge will be lost from that one? So this is just the representation, that how you will represent the losses from an irrigation canal. Okay. Second one, we can represent the losses in terms of depth of water. Okay, that for example, if you have a canal of uniform cross section and you measure the depth at this point and measure the depth at this point, okay, so if the rest of the condition is uniform, or if the rest of the conditions are equal, and if there is difference between the depth of the water in these 2 points, so it will be a type of loss. For example, if here the water depth is 5 centimeter and for example here the water depth is 4 centimeter, so that 1 centimeter will be considered as a conveyance losses, that will be considered as a transportation losses. Okay. Secondly, we can also represent the losses in term of percentage of discharge. Okay, percentage of discharge. For example, if here the discharge is Q1 and for example here the discharge is Q2. Okay, so then the percentage losses will be Q1 minus Q2 divided by Q1 multiplied by 100. Okay, so that will be taken as a percentage losses, that how much percent of Q1 has been lost by conveying, by transporting the water from this 1 point into 2 point. Okay, so that will be also as a representation for the conveyance losses. And also we can represent the losses in term of percentage of discharge loss in 1 kilometer. Okay, that for example, if you have 1 kilometer length of the canal, so how much water, how much percentage of the discharge has been lost? Okay, so these are just the different representation. If and if you look into these criteria, so see, also we can represent the losses in term of volumetric. For example, how much cubic meter of water has been lost from 1 square feet wetted area in 1 day. Okay, that is also the representation of the water losses in the canal. See how much cubic meter of water has been lost from 1 square feet wetted area in 1 day. Okay, so see the general losses of the water from the canal due to transpiration, that is 0.2 to 6 cubic meter. Again, that will be depend on the type of the soil and the environmental condition and on the condition of the canal. Okay, so if there is the proper and suitable condition, then in 1 day from 1 square feet canal area, wetted area, 0.2 to 6 cubic meter of water can be lost. Okay, and see the seepage losses, that is 0.6 cubics. 0.6 cubics of water can be lost from 1 million square meter wetted area. If you have 1 million square meter, if you have 1 million, see, if that is the 1 square meter, then you have another square meter, then you have another square meter, here you have another square meter. So if you have 1 million square meter area, then in 1 second 0.6 cubic meter of water will be lost in seepage. Okay, so these are just the different recommended and standardized value. And also we can say that 1 to 2% of the water can be lost through evaporation. Okay, so now see, based on these things, yeah, also we can calculate the evaporation losses by this one. For example, suppose if you have the change in discharge between the 2 points is delta Q, divided by the discharge at the first point is Q1 multiplied by 100. Okay, so that will be considered as a percentage losses per kilometer. Okay, that in 1 kilometer how much percent of the discharge has been lost. Okay, so if you have here Q1 and here you have Q2, so the difference between these two will be delta Q. So delta Q divided by Q1 multiplied by 100, it will give you the percentage losses in 1 kilometer from the given irrigation canal. Okay, so if for example if you are unable to measure the discharge at that two different points, then we can also calculate the difference in discharge. Okay, so see, the difference in discharge for a specific canal is equal to 1 over 200, okay, multiplied by b plus d to the power 2 by 3. Okay, where b is the bed width, d is the depth of the water. Remember, these will be in meter. Okay, these will be in meter. So you will get the we can say that you will get the difference in discharge per 1 kilometer. Okay, it means that if you have 1 kilometer length of an irrigation canal, if that is 1 kilometer, so how much change in discharge will be occur? So it will be equal to 1 over 200 multiplied by b plus d to the power 2 by 3, where b is the bed width and d is the depth of the water in meter. So you will get the change in discharge. Then the change in discharge divided by discharge at the starting point multiplied by 100, you will get that how much percentage of this Q1 has been lost in 1 kilometer. Okay, so see, if you design a very we can say that effective and efficient canal structure, but there will be some type of evaporation losses or seepage losses or transpiration losses. Okay, so now this is the most important question, that should a canal be lined or not? Now what is the, we can say that what are the advantages? What will be the benefits if you lined an irrigation canal? So see, as we have discussed the different types of losses, so if you lined an irrigation canal, so we can confidently say that these losses will be reduced up to some limit. Remember, we cannot reduce these losses up to 100%, but we can say that the losses will be reduced up to 80 to 90%. Okay, so up to certain limit we can reduce these losses. So this is the major advantage, yeah, this is the major benefit of the canal lining. Okay, so now let's see, as we have discussed that what is canal lining. Basically it is the treatment which will be provided to the canal bed and banks to make the canal section impervious. See, when the losses will be occur, the losses will be occurred when the canal section is pervious, when it is of the natural condition. Okay, so if such type of treatment has been provided, then what will happen? If such type of treatment has been provided, then the cross section will become impervious, and when the cross section become impervious, then mostly the seepage losses and transpiration losses will be controlled. Okay, and now see, when that losses has been controlled, so what will be achieved? Now see, if the losses has been if the losses has been controlled, so obviously the water will be conserved, the water losses will be controlled, and as we know that water is a limited natural resource, so we have to conserve it. Okay, so lining, before the decision is made to line a canal or not, now remember the cost and benefit of lining should be compared. That how much will be the cost occurred on the lining and how much you will get the benefits. Okay, so see, the water conservation is one of the major benefit which will be achieved from the canal lining. So lining a canal resulting in reduction the water losses. So the water losses in unlined irrigation canal can be high. Okay, if there is high loss in the unlined canal, so then it will be controlled, then it will be conserved, okay, by means of the lining of the cross section. Okay, so that is an important reason for lining a canal, to reduce the water losses, as water losses in unlined irrigation canal can be high. Okay, so for example, a canal which is carrying 30 to 150 liter per second, there may be 10 to 15% of losses due to seepage. Okay, for example, if you have a canal which is carrying from 30 to 150 liter per second of discharge, so there is possibility that 10 to 15% of the water may be lost only in seepage. So if you properly lined a canal, then this 10 to 15% of water will be conserved. Okay, so lining a canal will not completely eliminate these losses, but we can say that roughly 60 to 80%, 80 to 60 to 90% of the water losses will be controlled. Yeah, that amount of water will be saved, conserved. Okay, so minimizing the water losses is very important, and especially in scheme where irrigation water is pumped. Okay, suppose if you are pumping the irrigation water, so then it will be most important that you have to conserve the irrigation water so that the pumping cost may be reduced. And also most importantly, if the canal is unlined, for example, if the canal is unlined, then there will be seepage of water into the nearby area. If there is nearby, for example, if there is a road, or if there is nearby any agricultural land, or any for example, if there is any building, so if the canal cross section is unlined, then there will be possibility that there will be seepage will be occur into the nearby area. Okay, so if the canal banks are highly permeable or unlined, then the seepage of water will cause the wet condition or the waterlogged condition in the nearby area. So lining up such a canal can solve this problem. Okay, if you lined a canal, then this problem will be solved because the seepage will be reduced and the nearby area will be protected. Okay, also the reduced canal maintenance. See, the resistance to flow of lined canal is less than that in the unlined canal. For example, if you have an unlined canal and the water is flowing at a specific velocity, then there is possibility that the banks may be eroded, or the bed may be eroded, or the banks may be or the cracks will be produced. Okay, so if you lined the irrigation canal, then these maintenance costs or these maintenance things will be reduced, and also the flow velocity will be higher in lined canal. Remember, this is one of the most important point. Okay, if you have two canal of the same cross section and same bed slope and same we can say that wetted parameter and the flowing water velocity and the cross section is same and the longitudinal slope is same, then the velocity of the water in the lined canal will be 1.5 to 2 times greater than the velocity in the unlined canal. Is it clear? See, the velocity in the lined canal of the same cross section and same longitudinal slope, the velocity in the lined canal will be up to 2 times. It will be greater than the velocity of the unlined canal. So now if you can increase the velocity in lined canal, then we can reduce the cross section. See, we know that the discharge is equal to AV. So it means that if we are lining a canal, then we can increase the velocity. So if we can increase the velocity, so we can reduce, we can decrease the cross-sectional area. So if the canal cross-sectional area is reduced, then what will happen? Then the construction cost will be reduced. Overall construction cost will be reduced. Then we can say that when you are lining a canal, then small cross section will be able to transport the same discharge as transported by a larger section of unlined canal. Okay, so the construction cost will be reduced. Also reduce the maintenance, mean for example if you properly lined a canal, then the maintenance cost will be reduced, because then there will be no we can say that periodic damage will be occur into the canals. Okay, periodic removal of silt deposited, as we have discussed that in the lined canal we can increase the velocity. So if we can increase the velocity, then there will be no chances of the silt deposition. So if there is no silt deposited, then its periodic removal, its removal will not be required. Okay, and also the removal of weeds. See, in the unlined canal, different types of unwanted plants or weeds are grown. Okay, and if you are lining the irrigation canal, then there will be no chances, then there will be no possibility for that unwanted weeds. Okay, so its removal will not be required. So it will be also a type of advantage. Clear? More repair like plugging up cracks, uneven settlement of banks. Okay, these are more occurable, we can say that damages in the unlined canal, so these will be also avoided. So these are just the different advantages that if you lined a canal, so most importantly the losses will be controlled, the water will be conserved. Okay, there will be no seepage occur into the nearby area, the canal dimension can be reduced. Okay, the canal dimension can be reduced. So if you reduce the canal dimension, then the overall construction cost will be reduced. Okay, and no further more maintenance and periodic removal of silt and weeds that will not required as compared to the unlined canal. Okay, now it is an important feature, as we have discussed, to improve the flow characteristic and minimize the losses. Okay, so due to the seepage, to minimize that losses, we have to line the irrigation canal. So the water this saved can be utilized for the extension. For example, if you line an irrigation canal, so the water will be conserved. Yeah, the water losses will be reduced. Okay, so that extra water which is obtained, that extra water which is conserved, that can be utilized for irrigating some more area, so the irrigation system can be extended. Lining assumes special significance in pumped water. Remember, that is most important. For example, if you are pumping the irrigation water and allowing it into the irrigation canal, and for example if there is losses, so then you will have to pump more water so that to overcome that irrigation losses, that conveyance losses. So then the operating cost will be more. Okay, and for example if you are lining the irrigation canal, then the losses will be conserved, and then you will have to pump less amount of water because the losses will be subtracted. Okay, so the operating cost will be reduced. Studies indicate that seepage losses in irrigation canal constitute 25 to 50%. Okay, mean overall, if suppose there is 100%, if the overall in overall 100% losses, up to 50% losses are contributed from the seepage. So if you properly lined a canal, then this 50% losses will be completely controlled. Okay, and canal reaches having permeability of 0.001 centimeter per second, they must be aligned. Okay, they may be aligned because it has more seepage losses. And also experiments show that cement concrete lining has a rate of seepage of 0.5 cubic feet per second in 1 square feet wetted area. 1 million square feet wetted area. Okay, if you have 1 million square feet wetted area, so in 1 second 0.5 cubic feet of water will be lost. Okay, so this is a huge loss. So if we lined a canal, then this water will be conserved, and these water can be utilized for irrigating more area, so the irrigation system will be extended. Okay, so these are the benefits. Now see, we have different types of the lining. So the most commonly used lining are the concrete lining. Okay, mean different types of concrete blocks or concrete bricks or just simple concreting are used. Okay, shotcrete or plastic sheets are applied to the bed of the irrigation canal. Okay, similarly different types of tiles or brick lining. Okay, asphaltic lining and boulder lining. Okay, these are the hard surface lining. Yeah, these are called the artificial lining because some type of materials are utilized. And for example, if cement is not available, if sand and gravel is not available, then simply we can also line a canal by compacting the clay. Okay, see, if when you construct the irrigation canal, then apply some clay particle and properly compact it, wet it and compact it. Okay, so then it is called the compacted earth lining. Okay, or for example, if sand is not available, then the soil is mixed with cement and it is applied as a lining material into the cross section, yeah, into the bed and the banks of the irrigation canal, so that the seepage losses may be controlled. Okay, here you can see that is the cast in situ cement concrete lining. Okay, here you can see that just the concrete has been applied, and also sometime for better stability and for better we can say that efficiency of the canal, sometime reinforced concrete is applied. Okay, this is called the shotcrete. Okay, when the pressurized concrete is applied. Okay, yeah, when the plastic sheet is applied for the covering of this bed and canals of the irrigation canal, so the irrigation, so that the seepage losses may be controlled. But remember, there are also different advantages and disadvantages of each and every method. Okay, for example, if you are applying, if you are just covering the canal by plastic sheet, so that is one of the oldest method, okay, to reduce the seepage losses. Okay, so canal can also be lined with that plastic, but this material can be we can say that that can be damaged by the animals or by the weeds which will be grown below that plastic sheet. Okay, that can be we can say that damaged by machinery or people or animal. Okay, so similarly each and every method have different advantages and disadvantages. So we will look into the availability of the material. Okay, that in which area you are lining the canal, so either the material is properly available, what will be the cost, and how much benefit will be achieved. So these factors will be considered. Okay, here also you can see that the canal is lined by, we can say that different types of concrete tiles has been installed. Okay, this is also a type of paved concrete lining. Okay, so these are the different types. Also you can see that if for example if the clay is available nearby area, and for example if the brick preparation or brick manufacturing is easy, then the canal can be lined by different types of bricks. And also sometimes this prefabricated channel is available. Okay, these, see, you can see that this is a type of trapezoidal section. Okay, so it is pre-prepared, it is pre-prepared channels. Okay, and then these structure are just installed in the we can say that in the ditches which is constructed for the canal purposes. So again it will be a type of prefabricated channel section. Okay, and also this is one of the important point, that the thickness of the, we can say that, see, the thickness of the lining, that is depend on the capacity of the canal. Okay, for example, because the water will have some static pressure, or it will have some moving pressure which will be acting on the bed and the side of the irrigation canal. So if an irrigation canal have 0 to 5 cubic capacity, okay, and for example the depth of water is up to 1 meter, then 50 to 60 millimeter thickness of lining should be provided. Okay, and for example averagely if that we can say that if the capacity of the canal is from 0 to 5 cubic, then 60 millimeter, and if it is from 5 to 50 cubics, then up to 75 millimeter thickness of lining will be provided. Okay, so as we have discussed that when you lined a canal, then the almost the seepage losses will be completely controlled. Okay, prevention of waterlogging of the nearby area. See, if these banks are not lined, then the water will be seep, yeah, the water will be we can say that move into the nearby area, so the nearby area will be affected. Okay, this area will be affected. So if you lined a canal, then this will be controlled. Also, they increase the hydraulic efficiency. See, if the losses has been reduced, then as much as water you are entering at the head of the canal, so maximum amount of water will be available at the outlet point. So we can say that the conveyance efficiency, the transportation efficiency will be improved. Okay, increase the resistance to erosion and abrasion. Okay, also the unlined canal there are more chances of the erosion of the unlined canal. So when you lined an irrigation canal, so there will be more resistance. Okay. Reduction in cross-sectional area, as we have already discussed, that the velocity in the lined canal is almost 2 times greater than the velocity in the unlined canal. So if we can increase the velocity in lined canal, then the cross-sectional area will be decreased. Okay, so if the cross-sectional area is decreased, so it means that the construction cost will be reduced. Okay, low operation and maintenance cost mean for the lining canal there is no not further, and we can say that not too much maintenance and operation is required because the structure is already properly constructed. Prevention of weed growth, the most important thing. Okay, when you lined a canal, then there will be no proper environment will be available for the crop growths, for the unwanted plant growths. Okay, so if these weed growths is controlled, so also we can say that the transpiration losses will be controlled. Okay, elimination of siltation. See, when we can increase the velocity in the lined canal, so if the velocity is increased, then we can say that the silt which is present in the irrigation water, that will not deposit it. Okay, also the cement concrete is the most convention. See here, you can see in this figure that is just a simple cement concrete lining. Okay, that is one of the conventional type of the lining. Okay, and also in the lined canal, the velocity can be high as much as 2.5 meter per second. Remember, in unlined canal, mostly the average velocity will not be greater than 0.6 meter per second. Okay, and in the lined canal, we can supply the water, we can transport the water up to 2.7 meter per second velocity. Okay, but every construction have some, every type of work have some advantages and some disadvantages. So the disadvantages of the lining is that the initial investment will be high, because in the unlined canal only we have to construct or we have to dug the canal cross section, and if you are lining the irrigation canal, then again some additional component. Here you can see that the cross section is aligned, so additional tile or concrete or additional material will be applied, so automatically the initial investment will be high as compared to the unlined canal. Okay, also repair is costly. Most importantly, for example, if some breakage is being occur, or for example if some damage is occur, then this whole surface area will be properly dismantled and again it will be repaired. So as compared to the unlined canal, its repairing is costly. But remember, overall repair is less as compared to the unlined canal, but as compared to the unlined canal, its cost of repair is more. Okay, shifting of outlet is costly. Remember, for example, when you are lining a canal, so then there are some fixed point where the outlet is provided to the farmer. Now suppose if a farmer wants to take outlet at this point, then you will have to completely disengage, you will have to completely destroy this whole area, and you will have to provide this outlet, because once you lined an irrigation canal, then further works which you are doing in that lining canals, it will be a little bit difficult. Okay, so when you are lining a canal, so already some points are specified for the outlets, but if you are taking more outlets, some additional outlet, then it will involve the dismantling of, for example, of the of some specific areas. Okay, so then again it will be lined and that cost will be increased. And also remember, the construction period will be longer as compared to the construction period of the unlined canal. That first you will have to construct the unlined canal and then you will do the lining, so it will increase, it will prolong the construction period. Okay, so also sophisticated construction equipment and labor will be required. Remember, to maintain proper the side slope, the bed slope, and the level of the canal. Okay, some proper equipment and experienced or skilled labor will be required for that purposes. Okay, so this was all about the canal lining, that why we are lining a canal, what will be the advantages which will be achieved, and what are the different types of the canal lining. Okay, now see, we have the maintenance of the irrigation canal. Now remember, we will design the most efficient and most effective irrigation canal, and also we will improve the capacity of the irrigation canal. We will improve the efficiency of the irrigation canal by lining it. Now the performance of irrigation canal will depend on how the system is operated. Okay, mean the performance of the irrigation canal depends not only that how you are operating the system, but it is depend on the condition of the canal. Okay, as we have discussed that, okay, you will design the most efficient and most effective irrigation canal, and also you will improve its efficiency. Now how that efficiency will be maintained, how that condition of the canal will be maintained. Okay, so irrigation canal function well so long as they are kept clean and if they are not leaking. Okay, mean if there is no leakage, if the canal is clean, and if there is no damage occur into the banks of the canal, if the sediment which is deposited in the canal, if that is properly removed, then we can say that the efficiency of the system are maintained. Okay, yeah, the condition of the systems is maintained. And for example, if there is plant growth is being occurred in the canal, so automatically it will reduce the capacity, it will affect the performance, it will affect the transportation efficiency. Okay, so if no attention is paid to the canal system, plants may be grown and the problem of siltation may be raised. So the canal may suffer from leakages and from the from loss of the transportation water. So automatically we can say that the conveyance efficiency or the hydraulic efficiency will be badly affected. So these are the different parameters through which we have to maintain, we have to control the efficiency of the irrigation water. So see, if there is some unwanted material, if there is some we can say that if there is some particle is there, so we have to remove it from the irrigation canal. For example, if sediment is deposited, if for example if banks of the canal has been damaged or destructed by animal or machinery or humans, so we have to repair it. And here you can see that, for example, if weed is being if weed is growing in the irrigation canal, so again it will either lose the water through transpiration, or it will also affect the efficiency, the carrying capacity of the irrigation canal. So we have to remove that plants. Okay, so these things, if we are maintaining the efficiency, if we are maintaining the condition of the irrigation canal, then we have to properly provide some maintenance periodically and regularly. Okay, so see, there are after the construction of the irrigation system, it becomes essential to maintain it for its proper and efficient functioning. Okay, to maintain its efficiency, to maintain its working condition, we have to regularly and periodically we have to provide some maintenance. Okay, so there are various reasons due to which the canal may be function efficiently. See, these are the silting of the canal. For example, if there is some silt particle in the irrigation water, and when it is deposited, so as we have already discussed in the previous lectures, that it will affect the canal capacity. Okay, so if the canal capacity is affected, so automatically the canal efficiency will be affected and it will not work properly. And also breaching of the canal due to the weak banks. Okay, if the banks are weak, and for example if it is damaged by the humans or machinery or by animals, so then the water will overflow into the nearby area. So one problem is the area will be affected, and second problem is the water will be lost. Okay, and if the water is lost here, so the downstream canal will be we can say it become dry, and then no water will be available for the downstream agricultural area. And also we have the weed growth. For example, if the canal is unlined, and for example if the unwanted plant is occurred in that canal, so it will lose the water in transpiration, and also it will reduce the capacity of the canal. Okay, so these are the three things against which we have to maintain, or against which we have to maintain the efficiency of the irrigation canal. overflow of the canal banks. Okay, again, if sediments is deposited or wheat is occurred or the canal banks are, we can say that, damaged, then the water will overflow and it will be not proper amount of water will not be available to the downstream area. Okay, so see, silt removal, when the silt is deposited on the bed and sides, the capacity of the canal is reduced. So it is better to exclude that silt by providing silt excluder and silt ejector. The following measures are adopted. See, by flushing. For example, if you have a small scale irrigation canal and for example if sediments is deposited there, then see, it will be washed out by some pressurized water. Okay, just apply the pressurized water into the bed of the canal, then the sediment which is deposited, it will be washed out. So that is called the flushing. Second one is the silt scouring fleet. Okay, it is a type of blade. For example, if it is a type of blade and it is mounted, it is attached to a vehicle, for example a tractor, and then it is moved along the bed of the irrigation canal, so the silt will be we can say that removed or conveyed into the downstream portion. Okay, and also we have bundle of thorny bushes. Okay, this is just a local method that a bundle of bushes are taken and a canal has been cleaned with the help of that bushes. Also iron rakes, reduction of area flow, stirring up silt by water jet or dredging, or most importantly see by manual excavation, that manually labors are hired and they are taking out that sediments which is deposited into the irrigation canal. And remember that sediments are we can say that sediments are placed on the banks of the irrigation canal, so the banks are also properly the quality of the banks are also improved. Okay, second one, we have the strengthening of the canal banks. Okay, see, for example, if just in one point, for example if there if breakage is occur or if damage is occur only at one point of the irrigation canal, then the whole system will be affected. Okay, then the water will be overflow on the banks. Okay, so we have to properly strengthen it to prevent the breaching or the breaking of the canal bank. It should be strengthened properly so that valuable loss of the irrigation and property is prevented. Okay, see, the water loss will be prevented and also the nearby area will be prevented. Okay, so there are different methods that, for example, the external silting system. Okay, from the outside, for example, if this is the cross section, so from the outside here we are providing some silting material into the bank so that its stability is increased. Its we can say its stability or its breaching, its capacity against the breaching is improved. Okay, and also internal silting, mean from inside we can apply some silting material into the banks so that its width may be improved, it will be properly compacted. Okay, so the banks will be strengthened. And also formation of berm. Okay, as we have discussed in the previous lecture, that for example that is the side slopes, these are the sides, so here we are providing some berm and then we are constructing the banks of the canal. Okay, so if berms are provided, then the continuity of the slope will be break down and it will provide some more stability into the canal banks. Okay, formation of back berm. Sometime back berm is constructed from the back side into the canal bank, so that is also a method for strengthening of the banks. Third one, maintenance which is required to the irrigation canal, that is the weed control. Okay, here you can see that, for example, if the weed weed grown in the irrigation canal, so either it will utilize the water in transpiration or it will reduce the capacity of the irrigation canal. Okay, so water weeds are unwanted plants that grow profusely in water under certain favorable condition, because the water is available. Sometime if the canal is unlined, so it is a type of most fertile soil. So the soil is fertile, the water is available, the condition is favorable, so there will be high chances of the there will be the high chances of the occurring of the unwanted plant. So they tend to reduce the discharge capacity and also it utilize the water. Okay, so we have to remove that unwanted plant. So weed will be removed by one of the main method is you have to pluck it by hand, by manual method. Okay, here you can see that the unwanted plant will be plucked by some manual method and it will be burned. Okay, or we can also control it by this method, that when you apply the irrigation, then completely cut off the flow from the canal, completely stop the flow from the canal. So the weed, the plant which is available in the canal, then it will be exposed into the sunlight, and also there will be no water will be available. So automatically it will be, we can say that it will become dry, and then it will be unable to regain its strength. Okay, we can also decrease these things by applying the water with more depth. Okay, if the depth of the flowing water is more, then there will be no proper sun energy will be available to the plants, and its growth will be affected. Okay, so these are the different methods: the silt removal, the strengthening of the banks, and the weed control. So these things will be periodically and regularly applied into the irrigation canal, so that its capacity or its efficiency may be maintained. Okay, so this was all about the Lacy's theory and the lining of the irrigation canal, its advantages and types, and the maintenance of the irrigation canal. Okay, thank you.